To start today off, I want to just take one more look at mapping diagrams. After reviewing your homework, I saw there was some issues with it, so I'd like to go over. In a mapping diagram, we see that we have two sets of numbers, and they're paired together, their input and output. As we're looking at these, we could also write them as ordered pairs x's and y's. 1 is paired with 4, 2 is paired with 4, and 3 is paired with 6. Again, I can graph those. If they ask you for the domain, all they want is a list of those input values. If they ask you for the range, we're not calculating anything. Don't confuse range here with the mean, median, and mode range where you're doing some subtraction. This is just a list. Looking at our second mapping diagram, again, I could list the ordered pairs. I have 4 paired with 8. I have 6 paired with 12. And I also have 8 paired with 16. If they ask you to list your domain, it's the x values or input values. Your range is your y or your output values. Let's look at one more. Again, I can write these as ordered pairs. -2 is paired with 4. 0 is paired with 8. As arrows are pointing to them, 0 is also paired with 12. And 2 is paired with 12. Listing the domain, -2, 0, 2. I only need to write 0 once. Range 4, 8, and 12. This does not represent a function because I see 0 is repeated as an input, but it has two different outputs. This is not a function. Okay, it does not have one input for every output because the input of 0 has two different outputs. So now we're going to take this one step further, and we're going to talk about the rules or the equation part of a function. And we're going to look at something called slope-intercept form or function form, y is equal to mx plus b. We're going to be doing quite a bit of work with this form of the line. We're going to now use this example, y is equal to 5x minus 1. I'm going to take this function form and convert it to function notation by replacing y with this notation f at x. All I'm doing is just renaming the y. Why am I doing that? Because now I can evaluate at a given point. Instead of doing a whole table of values, I can now take this function and let's try simplifying this expression by looking at we can choose any input value, but in this case we're looking at 4. So 5 times 4, we're replacing the x right here. And then we're going to multiply 5 times 4 and subtract 1. So when we input 4, we're going to get 20 minus 1 following the rule. We'll get 19. So an input of 4 gives me an output of 19. Let's try the same with 10. Same rule, 5 times some number, in this case it's 10, minus 1. This equals 50 minus 1, and that's 49. So again, if I input 10, I'm going to output 49. Instead of, again, doing a whole table of values, I might only need to evaluate at a given point. So what are we doing? We're replacing y with f of x. Here is my equation. I'm going to take out the y, replace it with f of x, and now evaluate at a given point. So when I input 0, I output 2. I could take f of x and replace that with negative 4. So that's going to give me, let's put that negative 4 here. I'm going to get 4 times negative 4 plus 2. Negative 16 plus 2 gives me negative 14. Input negative 4, output negative 14. So we're going to do a little more practice on setting up a table of values and evaluating again in function notation. We'll do this one in class. We're first going to realize that this is not in function form, so we now have to solve for y. And we're going to look at that and see how we're going to subtract 2x over to the other side. And then we're going to replace that with f of x, and we're going to evaluate. That takes the place of the full function table, and we'll do more in class.